All right, let's get a little more practice graphing on restricted domains. So I want you to graph this function. It's f of x, and it is a linear function. It's like an mx plus b situation. So I'm going to start graphing, okay, at 2, my y-intercept. And then I have a positive slope. I'm going to go up 3, 1, 2, 3, and to the right 4. 1, 2, 3, 4. Okay, and then I'm going to go down 3, 1, 2, 3, and I'm going to go to the left 4. All right, so I made some little stray marks here. I'll get rid of those. But these are my little helper dots. Now I need to figure, before I draw the final graph, what domain I should be drawing it on. And this is telling me that it wants me to go from -4 to +4, and it's closed on both sides, which means a closed dot, and it is inclusive of the endpoints. So I'm going to make sure that this is a closed point and not an open point right here. Okay, so I'm going from -4 to +4 on my x's. So if you look at your x values, you have graph that exists between -4 and +4, but it does not go past those points. It is contained within -4 to +4. Okay, so that is the graph part. Now let's look at the range of this function. So the domain goes from left to right, okay, but the range goes from bottom to top. So we're going to go from bottom to top, and I'm starting, the lowest I go is -2, and because this is a closed point here, that's inclusive, so we're going to close it. And then it goes all the way up until it hits 5. That is the highest point that this goes. And this is also a closed point right here, so we're going to close the interval with a square bracket. Okay, so let's clean up this graph a little bit. We have graphed this function on the domain -4 to 4 inclusive, which means the endpoints are closed, and then we stated the range. Okay, another example is another line here. We're going to say the domain is all the real numbers where x is greater than -3. Okay, so there are a couple ways to do this. I can graph this line until I get to an x value of -3. Or I can go ahead and start at -3. If I start at -3, all right, if I use this as my starting point, then I can find f of -3 and start my line from there. Well, f of -3 is -3 minus 2, so +3, right? This turns to a +3 minus 2, which is 1. So at -3, my function value is 1. Okay, so I'm going to put a teeny little dot there, and then we're going to look at this a little bit further. Is x allowed to be -3? It's not. It's going to go all the way up to, but not include -3. Oh, my little helper dot was the wrong dot. It should have been on -3, right? -3, 1. So at -3, x goes all the way up to -3, but does not include it. So we are going to put this open circle there at -3, 1. All right, and that takes care of the fact that I have a greater than sign there and not a greater than or equal to sign. All right, from there I know that I have a negative slope, and so I'm going to go down 1 over 1, down 1 over 1, down 1 over 1, double checking if I'm doing it correctly. I'm going to hit my y-intercept at -2. Okay, and I'm just going to graph all the values that are greater than or equal to -3, so x, all the x's to the right of -3, and that's just going to keep going down like that. Okay, the range of this function, if I'm going from bottom to top, low to high, I'm going to start at, well, this was given to me in set notation, so I'm going to give this back to them in set notation. I'm going to say all the y's in the real numbers, where y is, it has a value that there's like a maximum value for it, right? So y is going to be less than 1. not less than or equal to because of this open dot. Y does not ever get to equal 1 because it goes all the way up to, but does not touch 1. So y is strictly less than 1. Okay, that's the range of this in set notation. And then, let's get rid of this guy. For what values of x is f of x less than or equal to 0? Well, f of x is less than or equal to 0 when this graph is, below the x-axis, right? So the values of x that are less than or equal to 0 start right here. That's where I start being less than the x-axis. And then it's going on forever, right? So all the way to the right, from this point to the right, my graph is going to be below the x-axis. So the way I say that is it's less than or equal to 0 for all x's in the real numbers, where x is greater than or equal to 2. Okay, because this is greater than or equal to 0. So at 2, I've made a mess of this graph. Let's see if I can clean this up a little bit. All right, at 2. All right, the function equals 0. Anything to the right of 2, the function is less than or equal to 0. Okay, so we can include 2 in our notation. We can say that anywhere x is greater than or equal to 2, the function will be less than or equal to 0. All right, so now I have this domain. I want to graph this function from -6 to 2. All right, I'm going to start at the y-intercept for this one and see where it takes me, because I know that the x value 0 is in between -6 and 2, so it's as good a place to start as any. I'm going to go down 1 to the right 2, and then I've hit 2, so I'm done there, because I can't go any further right than 2, because that's what my domain says. And then I'm going to go up 1 to the left 2, up 1 to the left 2, up 1 to the left 2, until I hit 6. All right, so 6 is included and 2 is excluded. So at 2, I'm going to make this an open circle, and at 6, I'm going to make this a closed circle. And then I'm going to connect those 2 points. Okay, so I have a line that's on the domain from -6 inclusive all the way up to 2. I'm going to state the range in the same notation. So this one is inequality notation. So I'm going to say the lowest that this function goes is 1. And it's not included because this is an open circle. So y will be greater than 1 and less than or equal to 5, which is the highest that this function goes. Okay, so it goes as low as 1 and as high as 5. And for what values is f of x greater than 2? So if we want something, before it was, in our last example, we were less than or equal to 0, which was an axis, which is a line that's already drawn for us. But now they want to know where is it greater than or equal to 2, so we're going to have to draw our own line. So I'm going to draw this little dashed line at 2, just so I have a visual. My function is greater than 2. This function is greater than 2 here. Okay? And when I am describing where the function is greater than 2, I'm going to describe it using values of x. So I'm going to say the first x value, the farthest to the left that it's greater than 2, is -6, closed. All right, so it's greater than 2 from here until here. And then it is greater than 2 until 0. And at 0, it equals 2. And this is not inclusive, so this is an open parentheses right there. All right, so for what values of x is f of x greater than 2? It's greater than 2 from -6 included to 0 excluded, because I'm not allowed to equal 2. And that is that answer.